Hi, my name is Leslie, and today I will be talking to you about one specific toolkit function. That toolkit function is y equals square root of x. I'm going to give you a second to take in this graph and see what it looks like.
It just runs along the y-axis forever, never actually touches.
Now I want you to notice that this graph does in fact start at the origin 0, 0, and its end is infinite. And I want you to find the characteristics with me. In domain, by domain it's basically just asking you for the x. And if you notice, the graph never goes below 0 or to negatives. So you can write the domain as no negatives or x has to be greater than 0. Now the range, for the range, you can look at all the numbers that y can be, and if you notice, all numbers can be greater than 0. See? That way and this way. So we can just write it, y has to be greater than 0. Now for the x-intercepts, we want to find out where the graph touches x-axis. And notice, like I said, it would be the origin, which is 0, 0. For the y-intercept, it also touches the y-axis at 0, 0.
Transformations.
Now for increasing, this line is in fact increasing, and all the x values are increasing because the graph is going to the right. So we just write all x values. For decreasing, no numbers are decreasing because the line starts here. So we can just put none for decreasing values. Concavity, if you notice, even though the graph is going up, or in this case the curve is up, the concavity is down. And this right here would be the concavity. And asymptotes, the line does touch the x-axis at one point, so it has no asymptotes. You can just write none. And now I wanted to show you the difference between y equals square root of x and the natural log of x, because they're very similar. And if you look in the calculator and you type in the natural log of x, you see how similar they look, because y equals square root of x starts right here. In the calculator it looks like it's touching it, but it's barely going. The difference is that in the natural log of x, the numbers seem and appear to get closer to the y-axis, but they never touch. Y equals the square root of x, in fact, do touch at the origin.
Exiu Barrera, if you're
0, 0.
If you're in the building, come to the front office. Exiu Barrera.
Now I want to show you a vertical flip. And vertical flip would be, here is our y equals square root of x, and to make our vertical flip we have to type the negative square root of x, and that gives us our vertical flip, which is down here. For our horizontal flip, you want to put the negative sign in front of the x to give you the original is this, y equals square root of x, and horizontal flip is y equals negative x inside the square root sign. Now translation, if we want to move it left 4 and down 2, what we need to change is the number behind the x. You have to add it to move it to the left, which seems odd, but that's how it works. And then if you want to move it down 2, you have to simply subtract 2. And then that should give you I should give you this graph, which looks like this. And that is it.